questions over the homework? Questions over the homework problems? Any of them that you all want to see done or work? Questions over the homework, guys? No? All right, guys, let's focus in. So what we're doing today is solving rational equations. Solving rational equations. This is the last part of this chapter, is solving these rational equations. Seeing what values of x will make this statement, this equation, true. Now, one of the first things, or one of the things we do need to pay attention for, is the restrictions. This is the first part where our restrictions are actually going to be important. Because if we get a value of x as the solution, that would make one of the denominators, or more than one of the denominators, be 0. It's not going to work. So the two denominators, the places where we could get a division of 0, is x plus 1 and 4x plus 5. So if a value of x that we get when solving this here makes either one of these be 0, it's not going to work, and we would throw that solution out. So with our x plus 1, first thing we can do in solving for x is we can subtract 1, telling us that if x is negative 1, one of the denominators is 0, we can throw it out. We don't even have to plug it back in to check it. The other is 4x plus 5. To solve it, we would subtract 5 from both sides, telling us 4x is equal to negative 5. Divide by 4, telling us that if x is equal to negative 5/4, we'd have a denominator of 0. That does not work. So this here has told us the two solutions we cannot get. If we get one of them, we have to throw it out. It does not work, and it would be called an extraneous solution. Now, just like with our complex fractions, our first thing we're going to look for to help us solve these, to help us make these easier to solve, is we need to find the least common denominator between these two terms. Now, we need to make sure that neither one of these factors, well, x plus 1 is as simplified as it gets, 4x plus 5 is as simplified as it gets. There's nothing in common with the x and 1 or 4x and 5. So these are as simplified as they get. Now, we know that x plus 1 does show up at least once in one of the two terms, so we'll need it once in our least common denominator. The 4x plus 5 does show up once, so we need it once. Questions on how we found this here? How we found the least common denominator? Now, unlike with our complex fractions or our adding or subtracting expressions, we don't have to multiply this on top and bottom. What we're going to do is multiply through the entire expression. Every term is going to be multiplied by our x plus 1 and 4x plus 5. Because the goal of this here, and the goal of using the least common denominator, is to simplify every fraction out. We want to simplify them all down, so we're not dealing with fractions anymore. We're dealing with a polynomial expression. Now, when we do this multiplication here, on the left, we're going to have our 3 times x plus 1 times 4x plus 5 over x plus 1 is equal to 9 times x plus 1 times 4x plus 5 over 4x plus 5. So we want to multiply every term by this least common denominator. And now that we've multiplied every term by it, let's see what simplifies. On the left-hand side, the x plus 1 and x plus 1 are going to cancel. On the right-hand side, the 4x plus 5 and 4x plus 5 are going to cancel. And what that leaves us with is 3 times 4x plus 5 is equal to 9 times x plus 1. And that's the nice thing about using this least common denominator, because when we multiply through, instead of having two fractions on either side, we have two expressions. We have two non-rational expressions. And we can solve from here. Questions on this so far? No? First thing we can do on the left-hand side is distribute the 3. 3 times our 4x is 12x. 3 times 5 is going to be plus 15. On the right, we can distribute the 9. 9 times x is going to be 9x. 9 times 1 is plus 9. 12x plus 15 equals 9x plus 9. Now, since all of our x's, we don't have an x squared, we just have an x to the first power. We just need to get x on one side, everything else on the other. So what can we do to do that? What can we do to get x by itself? So we would need to move the 9x over, yes? And since the 9x is positive, we can minus it. We can subtract it. Because on the right-hand side, 9x minus 9x is 0, leaving us with 9. On the left-hand side, 12x minus 9x is going to be 3x plus 15.
So if it equals 0, it's just
because it gets rid of the x, because we write it underneath for especially like why that becomes 0.
Oh yeah, the 9 is
Yeah, no, you're good. No, that's a good question, because again, we're making sure we know what's going where. Yeah, because the 9x minus 9x would give us 0x plus 9, which would indeed just be 9. Then we can subtract 15 from both sides. Nine minus 15. And lastly, we can divide both sides by 3. Now, is that one of our restrictions? Because our restrictions at the top were what? -1, 5/4.
yes.
Nope, neither one of those, so that works. That means that is our solution. Questions on this here? Now, most of this is just revolving around, or the big step for this is making sure we get that least common denominator, our expression that we need to multiply everything by to get the fractions to simplify. -5/4. Let's look at the next one. 2 over x plus 2 equals 10 over 3x plus 2. X plus 2, 3x plus 2. Both of those are factored as simplified as they get for our denominators. So for our restrictions, it means that x plus 2 cannot be 0, and 3x plus 2 cannot be 0. For x plus 2, we can solve it by subtracting 2, telling us that if x is -2, we'd have a division of 0. It would not work. For 3x plus 2, our first step would be to subtract 2 from both sides. And then we'd have to divide by 3, telling us that x cannot be -2/3. So if we get -2 or -2/3, it would be one of our restrictions. We throw it out. And the nice thing about the restrictions is that we don't have to go back and actually check it. We don't have to go back and plug both solutions in or plug all the solutions in to see if it gives us a true statement or not. The restrictions tell us immediately if one or all of the solutions don't work. We don't even have to plug them in. It will tell us that they don't work. Least common denominator. Well, so if we look at the denominators, x plus 2 is a factor in one of the two denominators. Shows up once, we need it once. What else do we need? 3x plus 2, because it is a factor in one of the two denominators. It shows up in one of the denominators at least once. And so what we're going to do is multiply, yes, the entire equation by this x plus 2 times 3x plus 2. Because again, the goal is to get the denominators to simplify out. And as we saw with the last one, well, on the left-hand side, the x plus 2 and x plus 2 are going to cancel out, leaving us with 2 times plus 2 is equal to. On the right-hand side, the 3x plus 2 and 3x plus 2 will.
10 times x plus 2.
Because I wrote it out the first time so that we can see how that simplifies. Once we get that and understand what's going on, we can just cancel it out here. We don't necessarily have to rewrite it back out. Now at this point here, we can distribute the 2. 2 times 3x is 6x. 2 times 2 is plus 4. Here we can distribute the 10. 10 times x is 10x. 10 is 20. Questions on this here? What can we do next? Yes. We can subtract 4 from both sides, telling us that 6x is equal to 10x plus 16. What can we do next? We can minus the 10x. Telling us that negative 4x is equal to, yes, and lastly we would divide by negative 4.
So that's what, negative 4?
X is equal to negative 4.
That's not a restriction.
It's not one of our restrictions, so x is equal to negative 4. Questions on this here? Questions on anything we've done so far? So here, our two denominators that we have are 5x and x minus 7. So what times 5 is going to be 0? So what would I multiply 5 by to get 0? 0. So it tells us x can't be 0. X minus 7 equals 0. So what minus 7 is 0? Plus 7, positive 7, because 7 minus 7 would be 0. So x can't be 7 or 0. We get one of those two as an answer, we can throw it out. Least common denominator. Or what are we going to need to multiply this through by?
I do see where you get restrictions. I just know that's what it's supposed to be.
Yeah.
Use all my legs?
Mhm.
You've been sitting here drawing M's the whole time. No, I'm not going to do no. No, that's
think that's the same thing. So looking at this one here, I know we're going to have to multiply by 5x and x minus 7. Because here the 5x and 5x would cancel. Here the x minus 7 and x minus 7 would cancel, leaving us with 3 times x minus 7 is equal to, well, 2 times 5x is 10x. Too far. Distribute the 3. 3 times x is 3x. 3 times negative 7, negative 21. I would, yes. I would subtract the 3x. X equals negative 3. Not one of our restrictions. That's it. Questions on this here? Negative 4 over x plus 3 equals 5 over x minus 3. There are 2 places where we could have a 0 is either at x plus 3 or x minus 3. Because if x is negative 3, one of those two is going to be 0. If x is positive 3, the other is going to be 0. Positive, negative 3. Let's see what we multiply everything by. Now we only use each factor once because in each of the denominators it only shows up once. Because after multiplying through by that least common denominator, we're left with negative 4 times x minus 3 is equal to 5 times x plus 3. So here if we distribute the 4, negative 4 times x, negative 4x. Negative 4 times negative 3 is plus 12 is equal to, on the other side, 5 times x is 5x. 5 times 3 is plus 15. Yes. Because our first step, especially at this here, since we don't have a quadratic or a higher degree polynomial function, there's a lot of first steps that we can do. Because one of them is adding 4x to both sides. We could have also subtracted 5x from both sides. Or subtracted the 12 or subtracted the 15. Now it's minus 15. So 9x is equal to negative 3. And lastly, negative 1/3. Positive or negative 3? Yep. Yeah. Luckily it's not, so that is our solution. The value of x, I will make both of these be the same. Questions on this here? You know what? We'll stop here for today.